So in this video I'm going to discuss Codeforces around 945 rated for division 2. So I will be solving first 3 problems in this problem set. So let's start with problem B, that is cat, fox and lonely array. So what is question asking you to do? So I will discuss question here. Okay. So wait a minute, let me erase this part. Okay. So for example, you are given an array of total n size. Let me take it here only. Okay. So for example, you have to tell what is the minimum possible k. Okay. So what is a k in this question? So k is simply that you will select any two indexes in this array. For example, let it be this index or let it be this index. It can be any indexes. So after choosing any two indexes in this array, you will now make a OR of from this index to the next k array. For example, in this case, let's suppose k is equal to 3. So the which means the OR of these three numbers should be equal to OR of these three number, and it should be valid for all the I and j pair. For example, what in this simply means the each and every subarray of size k should have the same OR. Okay, so this is what question asking you to do. Let me repeat. If you have to find the minimum possible k, you have to find the minimum possible k such that a OR operation of all the subarrays of size k is equal. Okay, so how to solve this problem? So this question is very much easy, but why? You can simply use binary search for this question. But how? Let me tell you why. So for example, let's suppose I give you a number. For example, let's suppose I give you a number like 3 only. Okay. Now if the minimum answer is 3, let's suppose minimum answer is 3 4 in this case. So if the minimum answer is 3, then the array of then the k is equal to 4 is also valid. But why? Let me tell you why. For example, I'm taking this array again. Let's suppose in this question you are given two arrays like this array, and let's suppose next will be this array. Okay, you know that the OR operation of this is equal to the OR operation of this, because k is equal to 3 is valid. We have to prove if k is equal to 3 is valid, then why k is equal to 4 is also valid. The answer is pretty much easy, but why? You know the XOR of this is equal to this. Okay, also the the OR of this is equal to OR of this, right? Also, you also know OR of this is equal to OR of this, right? This is also equal, which means let's suppose I'm taking white as I'm taking this as A and taking OR of this as B. Okay, great. And this is equal to this, you know. Also, you also know like that the OR of this I'm taking C and this I'm taking D. The OR of C is equal to OR of D. Okay, and you also know one thing, your A is equal to C. But why? You know that for k is equal to 3, your all the subarrays of size k have a equal OR. So if this is having a OR is equal to A and this is having a OR is equal to C, then A is also equal to C, right? Similarly, B is also equal to D, right? If if all these four equations are equal, then you can also say that like A or C is also equal to, let's suppose, B or D. Okay, you know that this condition is also valid, and you know what is this condition? This condition is representing k is equal to of size 4, which means for each and every subarray of size 4, your condition is also valid. Okay, so I hope you have understood this much part. Okay, let me repeat why, but let me repeat again. So I will only repeat the conclusion. Like if your k is equal to 3 is a valid, then every number greater than equal to 3 is also valid. Okay, the proof I have shown you previously. Okay, so now how to solve this question? So you will iterate for each and every iteration from 1 to n and check if this is a valid number. If this is a valid k, then what you will do? You will iterate in the smaller part of the array, which means now your next subarray is like this, because you have to find the smallest k. Okay, if this is a valid number, okay, for example, let me take this is not a valid number, which means you have to now increase your search space from this to this. Now you know if this is a valid number, then this can be answer. Okay, so that's how you can use the binary search. But how to find whether for a particular k your answer exists or not? This is also this is also pretty much good problem. Like I have told you that you can use binary search for this. For each and every k, try to find whether you can make all the subarrays of size k of equal or operation or not. And by using this you can find the answer. But how to perform that operation, which means how to find for a particular k is all the subarrays of size k have a equal or no or equal or not. So let me tell you how you can solve this problem. So for this particular sub problem you can use a sliding window approach. But how sliding window approach? Let me tell you why. Let me tell you how. So let's suppose I'm taking example like this only. This is a pretty much good example, I could say. Okay, so okay, done. Let me take what is the answer. For this answer is 3. Okay, for this answer is 3. So let me now debug only 3. Okay, because we know the answer will always come. So let me now try to debug for each and every case. So what we do in sliding window, we took a window of size 3. Okay, and now we try to move the window ahead, right? Okay, so this is a binary search. Okay, this is what we do in binary search. But how we can add a operation and neglect a operation? This is also easy. Okay, so I will first of all make a array which represent the bits of your number. Okay, so what is a binary representation of 0? The binary representation of 0 is only 0. So I will make my array 0 0 0. Okay, now I will move to the next number. This is done. Now I will move to the next number, that is 1. So binary representation of 1 is only 1. So at the position of 1 I will increase it in 1. First, oh, I will increase 1. Okay, okay, done. So I will make it equal to 1. Okay, this is now equal to 1. I'm only increasing. Now you know what is a binary representation of 3. The binary representation of 3 is this 1 1 0. Okay, this is a binary representation of 3. Okay, but what I will do, I will add the binary representation of 3 in my this array. Okay, then what is my final array would look like? Now final array would be like this is become equal to 2 and this is become equal to 1. Okay, great. Now these three numbers are covered. Okay, great. Now what you will do, you know that if your what is the OR operation? If any of the number is 1, then your whole then your that bit will be 1 at the end only. Which means in this case you know at this position you have previously occurred two ones, that is in case of 1 and in case of 3. Then at the end in the binary representation of these three, then in the binary representation of all of these three numbers, this number would be 1 at the end. Yes, this number would be 1 at the end only. So I will write 1 here. Okay, great. Let me change the color. I will write it 1 here. And you know for this 1 is occurring one time, that is in case of 3. So I will write 1 here and 0 0 here, which means the binary representation of all of these three numbers 0 1 and 3 is this only. Okay, great. So you know one thing, like this is my window size 3. Now what I can do, I can increase my window. How I can increase my window? To increase my window, I should remove 0 and I should add 2. But how? So what is a binary representation of 0? That is 0 0 and 0. And what is a binary representation of 2? That is 0 1 and 0. Which means from this array I will subtract this part and I will add this part. Okay, that's how I can get a binary representation of all of this part. Which means now 0 is excluded and 2 is added. What I have done, I have minus the all the bits of zeros and I have plus all the bits of 2. So what is my final array would look like? My final array would look like, just I will simply erase this is equal to 0 and this will be equal to 2. Okay, great. So this is the whole intuition. So now tell me, what is a binary representation of this new array? This is also equal to this part only, because two represents one only, because here my one is occurring two times, which represent the final at then one only. Okay, great. Now I will try to find binary representation of these three numbers, which means I have to again add 2 and I have to remove 1. But how? What is a binary representation of 1? That is 0, 0 and 1. I have to subtract this part. And what is a binary representation of 2? That is 0, 1 and 0. And my final array would look like I am minusing this, that is 1. I am adding this, that is 3, and this is 0. Now this is my OR operation of this sub array. You know, this is my OR operation of this sub array. Hope you are getting it. How I am getting the answer. Now you one thing. Now this is a binary representation of these three numbers. So what is the final OR? The final OR is this only, because 1 represents 1, 3 represents 1, and 0 represents 0. Now you can increase your subarray. This is your next window. What you will do? You will simply add 1 and you will subtract 3. But how? Let me debug this test case also. Like now this is your final array. What you will do? You will simply subtract 1, that is 0, 0 and 1, and you will add 1, this is 1, and you will subtract 3, that is 0, 1 and 1. So what is your final array? Your final array would be plus 1 minus 1, that is this 1 only, and here you're subtracting 1, that is 2 and 0. Now you also know, if this is a number of ones occurring at this bit, then at the end your OR operation will represents 1 here, which means 1 over here, and 1 and number of ones over your this bit is 1 only. So this will also represents 1 only. So the representation is same. So that's how you can solve for each and every test case, which means just use a sliding window approach. Okay, just use a sliding window approach and find the OR of this operation, and please maintain this array which represent the number of set bits at the current position, at the current position, and how to construct this array, which represents the final OR of that subarray. If the any bit is set on the ith bit, then your that bit is 1. If your none of the bit is set on that index, or I can if ith bit is set, if the none of the ith bit is set, then you will simply make it 0. If any of the ith bit is set, then you will make it 1, and simply store this array in any set or anything else, and try to find if the how many different number you have generated using this. So that's how you can solve this problem. If I show you the code, this code is also very much easy. So this is the binary search function which I am using. Simply try to find the operation. If at the ith position my answer is valid, then I will simply decrease my r, or I will simply decrease my right of range and make answer is equal to m, or else I will increase my answer. And what is this function? This function represents my let sliding window part. So okay, great. Then how I will tell you this is, so for example, this is the array which I am maintaining. Okay, what I have to tell you, like for example, this is 0, 3, 2, 5, 1, 0. Okay, great. This is my data array, which represents the number of set bit on the ith position. I know 64 is big. I can make it smaller also, but leave it anyway. So this is my operation. Operation represents if I am passing 1, which if I am passing 1, which means for this number, please add the bit. Please add the bit to my value. If my operation is 1, you can simply see I am adding the value of the ith bit. Okay, great. Now, if my size is smaller than k, then simply increase the size. This is normal sliding window template. Okay. Now you know how to find this array from this array. You know, if your ith bit is set, then it will be 1. Ith bit is set, and then 1, 1, 1, 0, and 0. Which means if any of your subarray having this configuration in the sliding window, then at the end your OR of that subarray would look like this array only. So this array I'm generating here. If your ith bit is set, simply push 1, else put 0. Push 0. Okay, great. Now how to remove that ith part? Because you know I'm taking two pointer approach for the sliding window. My I is the previous pointer and j is the next pointer. Simply you have to now I'm removing the ith point. For example, in this case you can see if I want to generate subarray for this part, then I will simply remove 0 and add 2. And for removing 0, this is the point where my I is. Now to remove 0, what I have to do, I will again call my this operation OPR and passing a value 0. My 0 represents please remove the ith bit is set or not from my current value array. Okay, value array represent the number of set bit on the ith position. Then if my operation is sending 0, then simply remove that part. If my operation is sending 1, here you can see if my operation is sending 1, then uh, and when will I call this operation on each and every j. For example, if I want to calculate the answer for this subarray, then I will pass 1 for this and 0 for this, because I want to remove 1 and add 2. Okay, now for adding 2 I will pass 1, and passing 1 represents adding the bits of the number which I am passing. So that's how you can solve the problem. Okay, and now after all, you have to also check whether your size of set is 1 or not. What does this set contain? This set contains the OR operation of all the numbers. Okay, OR operation of all the numbers. That's what I'm calculated here also. So that's how you can solve the problem B. So this is how you can solve problem B. I will provide the code in the description part. So let's now discuss the problem number C, that is cat, fox and double maximum. So this question was also pretty much very greedy problem. But why I'm saying that very too much time, I will tell you why. So in this question, let me take a test case like this. Yes, this is that test case only. Okay, great. So what is question asking you to do? So this is a permutation given to you. Okay, great. This is a permutation given to you. You have to generate another permutation. Okay, let that permutation be this. That is 5. I'm taking answer only. 5, 4, 8, 2, 7 and 163. Okay, you have to generate another permutation like this. Okay, now what? By generating another permutation like this, you have to take sum of permutation which is given to you and permutation which you have found. Okay, now take the sum of both these numbers. This is equal to 6, this is equal to 14. Okay, now this is equal to 14, this is equal to 7, this is again equal to 14, this is equal to 7, this is equal to 12, and this is equal to, let's suppose, 6, and this is equal to 6. Now you have to find number of local maximum. Local maximum, I think so definition is pretty much clear, but you can read it here. The number of I which is greater than its previous and the next pointer are the number of local maximum. Okay, so what are the local maximum? This is a local maximum over here. Okay, this is a local maximum because it is greater than 7 and 7. By this, because it is greater than 6 and 7, this is also local maximum, which means in this question you can only generate 3 local maximum. Okay, so what question is asking you to do? Simply generate a array B. So simply generate a permutation which is an array B, such that if you find the sum of A and B, respective sum of A and B for I and I, then the number of local maximum in the final, let's suppose this is array X, then the number of local maximum in the final array X are maximum as possible. In this question, in this case, your local maximum are coming out to be 3. So the why is answer coming to be 3? Because I have chosen permutation B like this, and this is the best permutation I can choose to make my array A such that it is containing 3 local maximum. So this is a question asking you to do. But how you can solve this question? So I will directly jump to the solution. But solution means how you can approach this problem, like how. So in this question, what you have to do? You have to simply wait a minute. So in this question, what you have to do? You have to simply try to make alternating index differently, which means I will try to, for example, this is the 8 size array. So I will try to make my permutation be such that this is, let's suppose this is my permutation. Okay, what are they using? This is P and I have to generate, I think so, Q. Okay, this is my permutation P and I have to generate a permutation Q, and your final sum will be permutation A. Okay, I don't know what is my permutation Q. Okay, till now don't forget this part. Focus on this A part. So how you can get the maximum number of local maximum? So to get the maximum number of local maximum, you can make alternating index greater and smaller. But how? So let's suppose you will make this index as large as possible, and this is make as small as possible. You will make it as large as possible, and this make as small as possible, and repeat the pattern. Okay, and repeat the pattern. Which means in the whole question, what you will do, you will try to make alternating index. For example, you are choosing this index, you will try to make this index as large as possible, and this you will try to make as small as possible, because that is the only case where you can generate the local maximums. So if you make your alternating index maximum, so in that maximum you can try to find this can be a maximum, this can be a maximum. So this is the only condition where you can maximize the probability of getting the highest number of local maximums. Okay, so how you can generate the maximum over here? So this is also pretty much good question, like what number I should place in a queue such that your final array A in that array your alternating index are maximums. Okay, but how to choose which to consider and which to not to consider? Okay, mm, wait a minute. Okay, I have written the test case, but I'm just reading that only. Okay, so what you will try to make like that. For example, I will write array over here 2 3 4 5 7 6 8 and 3. So what I will try to make is like that. I will try to make all the numbers minimum as possible, which are on the highest number possible. For example, in this case your highest number is 8. Okay, in this question your highest number is this 8. Okay, so I will try to place as small uh, I will try to place as small number as possible on this 8, such that this such that all the index which are on alternating index from this array are minimum as possible. Let me repeat again. So I will find the maximum number in this array. Okay, I will find the maximum number in this array, and all the numbers which are on alternating index from this index will be that number which would be containing my minimum sum. Okay, but what I was telling you is like that I will try to make alternating maximum and alternating minimum. Okay, so first of all find the maximum number. So for example, in this question my 8 is maximum, which means which means what I will try to make all the alternating index which are from starting from the 8 as minimum as possible, which means my 8 my this is my a, and I will this is my final array, let's go a. Okay, so in the final array a I will try to make my final index sum at this position to be minimum, similarly this to be minimum because this is at the alternating from my maximum number, this to be minimum and this to be minimum, and the opposite is justified, which means I will try to make this as maximum and this is maximum and this is maximum and also this is maximum. Okay, great. But how you can achieve this part? How you can make this is as minimum as possible and this is as high as possible? I think so that is very much easy part, because let me tell you why. So let me now try to construct the array queue. Now let me try to construct the array queue. So what are the minimum? So let me now try to separate out the numbers. Let me try now to separate out the numbers. That is 8. What were my numbers? That is 8 on this. What were my numbers on the minimum possible indexes? What were my minimum possible indexes? That is this 8, this 7, this 4, and this one. Which means I should add a number. So I should add that number in these numbers such that my sum is minimum by adding them in my A. So that is 8, that is 7, that is 4, and that is 1. So these are my number that will be containing minimum at the end, and opposite is also true, which means that is my 4, that is my 2, 5, 6, and 3. These are number which will be containing maximum number as possible. Okay, which means these are the number on whose indexes your sum would be as maximum as possible. Let me repeat again. These are those numbers on whose indexes your sum would be as maximum as possible in array A, and these are those indexes at which your final number would be that number on which indexes your sum would be as minimum as possible in final array A. Okay, hope this definition is clear to you. Okay, great. So how you can solve this problem now? So you know one thing, that your 8 is as maximum as possible. Okay. Now to make a now sort this, first of all sort these arrays. Sort both of these arrays. The minimum should be sorted in the decreasing order. This is already decreasing, and your maximum array should be in increasing order. And this would finally look like suppose this would be 6, this would be 5, and this would be 3, and this would be 2. So let me erase this now. Okay, now this is your maximum array and this is your minimum array. Okay, great. Now how you can get the smallest sum possible with the 8? The only condition to get the smallest possible sum with the 8, because 8 is your highest number. Just put the smallest number with the 8 and you will get the smallest sum possible. Okay, just put the 1, because 1 is my smallest number. Just put 1. Now your next smaller number in your minimum index is 7. Your next possible number in your minimum index is 7. Yes, it is 7. Now what number you should add with 7 to get the minimum sum? Now you know that 1 is already occupied by 8. Okay. This can be another number also, but 1 is already occupied by 4, but occupied by 8. Now you are only left with one operation. That is the only smallest number you are left with is 2 only. So with the corresponding 7, add 2. Okay, great. Now you are at index 4. Now you are at position 4. Now you know that your 1 is occupied in and your 1 is occupied and your 2 is also occupied. Then what is the smallest possible number you should add with 4 to get the smallest possible sum? That is 3, because 3 is the only number which is left with you. So I will add 3 here. Okay, great. Now you know. Now you are at 1. Now what is the smallest possible number you should add with 1 such that adding the sum and getting the number and getting the array A would generate the smallest sum possible. Now you know that what is the smallest possible number you can choose. 1 is 1, 2, 3 and already chosen. The number you are left with is only 4. Okay, great. The number you are only left with is 4 only. So you will choose 4. Okay, great. So let me remind you again. This is a minimum array, which means these are the indexes on which I'm trying to make the minimum sum possible. Though these are the indexes on which I'm trying to make minimum sum possible. And to get the minimum sum possible, just add the 1, 2, 3, 4 with the respective number in the final array. That is, with respect to 8, I'm adding 1. With respect to 7, I'm adding 2. With respect to 3, I'm adding with respect to 4, I'm adding 3. And with respect to 1, I'm adding 4. Hope so it is clear to you. Now for the maximum part. Okay, now for the maximum part, what to do? The answer is pretty much simple only. For the maximum part, for example, what you should add with 6 to get the maximum sum possible. So what, let me repeat again. What you should add with 6 to get the maximum sum possible. So that is the largest number possible. What is the largest number possible available with you? That is 8. And the size of array, that is 8. So simply add 8 here. Okay. Now what is the largest possible number which is available to you such that you can add in 5 to get the maximum sum possible? That is 7. Which means with respect to um, okay, let me get it. Okay, that is 7. I think so. I've made a mistake. Wait a minute. Okay. Great. Wait a minute. For two, okay, great. So for the maximum part, you have to sort the array in decreasing order. Let me tell you why. This is the only mistake which I was doing. I think so. That is 2, 3, 5, and 6. Okay, great. 2, 3, 5, and 6. So let me repeat again. I will remove this set. Okay, great. Now let me repeat it again. So this is your number. This is your smallest number possible. Now with the smallest number possible, you have to add the largest number which is available with you. That is 2. What is the largest number available with you? That is 8. So simply add then you will add 8 with your respective 2. Okay, great. Now 3. Now what is the largest number possible available with you which you can add with respect to 3 to get the maximum sum possible, because this is the maximum array. That is 7. Um, what is 3? That is 7. Okay, great. Now, what is the largest number available with you, which you can add with respect to 5 to get the maximum sum? That is 6. Okay, that is 6. Okay, great. Now, what is the largest number possible available with you so that which you can add in 6 to get the maximum sum? That is 5. Okay, great. So this is the final array. This is the whole solution. This is the final array. Hope so it is clear to you. This is the only solution of this. So let me try to debug for another test case. I think so. It is necessary. Mm, okay, great. So this is the last test case. So this would be the last test case which I will be explaining to you for this question. That is 5, 6, 1, 4, 2, and 3. Okay, great. Now, what is the largest number in this array? That is n. Okay. So the largest number in the array, for with respect to largest number in with respect to with respect to largest number in the array, you will try to make the your final array A as smallest as possible. Okay, great. So this is your final array A. This is the array Q which you have to find. This is the array P which you have. Okay. Now at this index you have to find, you will you this is the largest number possible. So with respect to largest number, you will try to make sum as minimum as possible and alternate that, which means at this position minimum, at this position minimum, which means at this position maximum, at this position maximum, and at this position as maximum as possible. Okay, now write down the numbers. That is 6 over here. This is the minimum sum possible. Now 1 over here. This is the minimum sum possible. This now 2 over here. That is the minimum sum possible. Okay, great. Now sort the array in the decreasing order. So after sorting the array, you will just replace the 1 and 2 only. So this is will 2 and this will be 1. Okay, okay, great. Now what next? Mm, now this is the your minimum array. And for the maximum array, what are the representative for the what are the representative for the maximum array? That are, you only know 3, 4 and 5. This is 3, this is 4 and this is 5. Let me erase these sticks because they are annoying. Okay, okay, great. Now this is the array which will be generating the maximum sum possible. So now let's start the minimum sum. To get the minimum sum possible, let me repeat. To get the minimum sum possible, what is the minimum number you should add with respect to C? With respect to 6 to get the minimum sum possible. That is available with you 1 only. Now with respect to 2, what is the minimum number you should add into to get the minimum sum? That is 2, because 1 is already used by 6. So let me write it 2 here. Okay. Now 1 and 2 are okay, but now what is the minimum possible number available with you which you should add with respect to 1 to get the minimum sum possible? That is 3. That is an okay, done. Now for the maximum part. So what is the maximum number available with you but that you should add with respect to 3 to get the maximum sum? That is 6. Okay. Now for the 4 you should add 5, and for the 5 you should add 4. So this is the final array which should look like. Now you know that. Now you know that greedily what you are doing. You are trying to minimize the sum. You are trying to minimize this, and you are trying to maximize this. You're trying to maximize this. You're trying to maximize this. So if you're trying to maximize this, and this, which means this is increasing the probability of getting your highest number of local maximas. So that's how you can solve the problem C also. I will show the code. The code you can understand. The code is also pretty much straightforward. So hope so you understood this problem. If you have any doubts in any of these three problems, you can comment me down. And please stay tuned for the next one. And please don't forget to subscribe my channel. And please don't forget to share my video also. Like, subscribe, share, and comment. And please share it with your WhatsApp group all where you want. And stay tuned for the next one. Thank you.